everyone, I am Sakshi Kesharwal and I'm a maths expert in AskIITians. So today we'll be starting with a chapter name that is known as what? Basically the symmetry, right? So symmetry is nothing. So I think so you know everything very well around you. So what is a symmetry? Symmetry means what? Like if you have something and you divide it into how many parts and then you should see that all the parts look alike, right? So if you're going to just divide it into any parts right from any side. So I'll give you one example. I have just sheet of paper right now. So I have written something over here and this is a sheet of paper, right? So something I just you don't see that. Okay, so this is a paper and I just open it, right? So can you see this? This is like just this half. If I just folded up this part and this part, both are same. And can I say that this part and this part looks like the same, right or not, right? So this is basically like this. Now I can fold this sheet of paper like this also, right or not? Yeah. So can you see that the upper half and the lower half remains the same, yes or no? So we see the symmetry in so many places. Now what happened, you can just draw a symmetry on a face also. How we're going to divide a body, so like you just draw a line from here, you see that the half part of mine and the half part of mine looks like the same, right? So anything means word symmetry, and here you'll be learning about the lines of symmetry and how many lines of symmetries you will be having, right? And there are like regular figures. For regular figures, you'll be learning some criteria for it, right? So you have to think little bit of imaginations, and you can use this in your day-to-day life also. Now, if you have and this is more relatable to your like in your day-to-day life, right? So right now I don't have paints and colors with me, so there are some activities. Please try this at home. I am just telling you what is we are going to do today. So there are some kind of activities. Actually I didn't when I was of your age, but you can also try this, and you can just do it. Now I don't paint, so I don't have the stuff with me, but you can just give a try. Okay, so let's get started with this thing. Can you see this? Yeah. So basically, we'll be starting with a symmetry. Can you see? So over here, you see that I'll be taking a little bit dark color pen. That's red will work. Okay. So what happened? You just see over here. I can just enlarge this. And this is okay, a little bit, not too much. It's like it became flat. Yeah, this will work. Okay. Yeah, it's okay. I'll just keep it this side so I can use this half of my board for my drawing. So I think so it's readable. Yeah, let me just see if you can, I can just extend a little bit like this. Yeah, then it will be more of readable. Okay. Yeah, now it's more readable. Okay, so we'll be starting with a chapter that's a symmetry, right? So symmetry means what? Just we'll go with the word, like anything which you divide, like you take the half of the part and that look like the same on this, right? So let's read it out, and I think so this will help you. So John Cate wrote a think of a beauty in a joy forever. When we describe a beauty as an object as beautiful, perhaps we mean that it is balanced and it has a regularity in the shape, right? So if anyone says yes, that's true. If anyone says yeah, you're beautiful, so we think like yeah, she's a perfect one, she's a good in everything, right? So every day we come across a number of the figures, object or structures that we have evenly balanced portions. So one half of the figure or the object or the structure is exactly the same size and the shape of the other half. That's the important, right? So one half, I'm just marking down the shape of the object. There is any highlighter in this? Yeah, I think so. This is a highlighter. Yeah, I'll change color. This is very bad color. I'll take yellow color. And let me just, okay. It says that the one half of the figure, object or structure is exactly the same size and the shape of the other half, and this property evenly balances the portion called the symmetry. And the figure objects or the structures which have exactly the balanced portions is called beta symmetrical. All the figures which around you are not necessary to be asymmetrical, but what happened? That all figures are not symmetrical, but some figures are symmetrical, right? So the above pictures of the architectural marvels are the beautiful because they are symmetrical. If you just give a close observation over here, so if you just see that this is what divided like this, right? I'm not using a pen like that. So can you see that if you take a close observation, like this part is just the similar, the half of the other part. Yeah, if you see the half part and you see the left half part, both are look like the same. So the above pictures are the archaeological marvels are beautiful because they are symmetric, right? So when we see the symmetric things, and like you see lots of flowers, right? When you see flowers and the honeybee comb, you see everything is very symmetric. If have you ever noticed a honeybee comb, it's very symmetric. You see like a sunflower, it's very symmetric. If you see around it, it's really very symmetrical, right? So the flowers, the natures, the leaves, when you see the leaves, all of them are symmetrical, right? And right, so look at the following figure. That let's discuss on the plane figure. So this is an arrow. So this is what beta line of symmetry. So we say this as, I'll just take a little bit. This is what line of symmetry, right? This is line of, this is called beta line of symmetry, right? Symmetry. So this figure is what, a symmetrical figure. So you drew a figure like this, and then again, can you draw like this also, right? Or not? You can divide this line. So this figure has what beta, two lines of symmetry. So what happened? Like you see the figures, you see that in how many ways you can fold the papers and get the same thing. So that is with that in that way we say that it have that many lines of symmetry. You can just lines of symmetry means what, if you're going to do in this way, like in a vertical way, horizontal way, or a diagonal way, right? So this is like, if you see this, if this is one, this one is said to be what beta, vertical symmetry. This is what beta said to be what, vertical symmetry, right? This is said to be what beta, vertical symmetry. And this one is said to be, if you're going to draw this one is said to be what beta, horizontal symmetry, right? Horizontal symmetry, right? Right, now what happened, you have a bird, you have a like mud, see this has been like marked over here, this is a smiley. So you have to make a section from somewhere so that the object looks like the same, right? So we observe that if the figures are folded along the specific lines shown as a dotted, each figures are left hand, and the left hand of the dotted lines fit exactly on the top of the figures on the right hand, right? Or not? So of the dotted lines, so each figure, so just see, okay, it's like one figure each, okay. Yeah, yeah. Just see over here of the dotted line, and each figure is divided into what beta, two coincident parts about the dotted line. Means if you're going to divide it, it has to look like the same. Like you cannot differentiate the left part and the right part, right? So if I've just rotated the figure in any direction, if I have showed you, you cannot say that this one was the left and this one was the right, right? So we have seen that the two halves are the mirror images of each other, right? Two halves are like basically what, the mirror images of each other, right? Each figure is divided into what beta, two coincident parts about the dotted line, and we see that the two halves of the what, the mirror images, right? So you can see that yes, this is a mirror image. If we place a mirror on the fold, and then the image of the one side is exactly fall on the other, then this lead to a what? Now this is basically a what beta, definition, right? This is, here comes the definition, right? So we'll just write it out. If a figure, I'll take green color for this, okay? So it says that if a figure is divided into two coincident, means like a mirror image, right, by a line, then the figure is called symmetrical about the line, and the line is called the line of symmetry, or the axis of symmetry, or a mirror line, and we say that the figure has a line of symmetry. Yes, so this is what it is saying. So you can just write it down in your copy, these lines. Okay, so I'm teaching you this because right now I need a figures, and I need a clear figures, and drawing on the board and sometimes showing you the video is like a very long process. So you can just go and it can be done a little bit fast also, right? So you just see that if the figure, if you're just going to fold the figure into two equal half, if I say, I have just shown you these two figures, if I say that this part and this part, these two are what beta, I cannot judge which part is the other one, right? So we say that now over here it says that the figure one, each of the figure one, two, three, each of them, each one of the pictures like 4, 5, 6 shown above is symmetrical about the dotted lines, and it is exactly, and this is what is called, as I wrote you, these are called as what beta, from the line which is been dividing, it is known as what beta, line of symmetry. And if it has a line of symmetry, if it is symmetrical about any of the point, or you can make a mirror image, then we say that the figure is symmetrical, right? Every figure is not symmetrical, right? It's not necessary that every figure is symmetrical, right? So you just see that over here, uh, it says that he made a figure like this, right? So if I make a like this, and like this, and oh, it's not very clear, I'll make like this. Hmm. Yeah, can you draw a symmetric, like any line that it is going to divide the figure? No, you cannot divide. Similarly, Over here, it says that two dimensions figure may have no lines of symmetry. It may have one line of symmetry or more lines of symmetry. Note that the adjoining figure has no lines. It has what? No lines of symmetry, right? No lines of symmetry, right? It you cannot divide. So now what I was discussing about, this is like the activity. That's why I kept it over here. I didn't like use it. So this is the, like, I will like to share with this thing to you. Just see, like, see, I think so we have done this in our act, like in our art classes, right? So what do you do? I think so I'll be sharing this thing. Just see, it's like that. It says that take a sheet of paper and fold it into half and spill few drops of the colored ink on in the one side of paper and press the half together on the flat surface and open it. Now the resulting figure is what? Symmetrical about the line folding shown in the by the dotted line? Yes or no? You just see that everything that, so this is what? A line of symmetry, right? So ink strain pattern, you can also do this again. So what you do, like, take a sheet of a paper, fold it into half, and take some pieces of a string and dip it in the variety of the colored ink or a paint and spread the strings on the half side of the folded paper. Now press the two halves together on the flat surface and open it. The resulted figure is what? Symmetrical about, and the line folded is what? A lines of symmetry. You can just try this. Yes, you can do this in your day-to-day life. Yes, and we have done this in a day-to-day life also. And cutting off a paper. Now I think so. Wait a minute. I have to do some little kind of adjustment. Yeah. Yeah. Just see. Now what happened? I think so everyone have done this. I'll also show you this. I have done, right? Uh, yeah. I can also show you this thing with the sheet of paper. Where is the sheet of paper I have? Let me just see. Oh my goodness. I have to take out a good sheet of paper because all the papers near me are like filled or it is in some use. I'll just show you, right? We can do this also. Hold on. Hold on. Just see. What I did, I just have this sheet of paper, right? And I just folded this into equal half, right? First, right? And then I drew something on it, right? So what happened if you want to draw? And this I did a lot of time, right? So just to make a craft in my, like, any time. So what do? You draw something on this, right? So I have a sheet of paper and I'm just going to draw something like this, right? I'm very bad at drawing, so please don't judge me, okay? Okay. And hmm, I drew a very bad figure. I can't show you here. Okay, let me draw a nice one. Okay. So yeah, can you see this? This is something I drew. Is it visible? I'll use a dark marker with you. Wait a minute. I think so it's not visible. I can draw with a marker. I kept something with me. Yeah. Yeah, I think so. This is clear. This is visible? I think so. Yes, this is visible. So I want to make a mirror image of this thing. Like I need a something which is like a flat surface, but right now I know if I'm going to just fold it like this and get the sheet of paper like this. So what happened? You can just open it and get the same thing. So what I'm going to do, I'm just going to make a cut from here, right? So I'll just cut it around the like this thing. So you just see if I'm going to make a cut. Yeah. So you'll get this symmetric figure like this. You just see. Very good. So just try this. Yeah, it has been a very, very long time that I did all this thing. So yes. You can draw something, whatever you feel like, a circle, semicircle, or whatever, like heart, or any figure you want to draw. Right. So can you see this? I'm opening right now. So can you see this? The half of it? Yeah. So this is the one half and this is the other half, right? If I'm going to make a border of it, so if I'm just going to close it, it's like overlapping to each other, right? Or not? Yeah. It's going to overlap this thing. So it means what? This is like one of the like activity which you can do, and the rest of the activity I don't have pen or something like with me, like liquid color. So otherwise, I would have shown you like how this activity would have been done. You what you do? You just drop a ink over here or some drops of the ink. Let me just try with the pen which I have, like with the marker, if it's works or not. Let's see. I'll just draw. But let's see, it's working or not. It's not working. Right. So you can just see this. So this is what beta, these are the two, this is what a symmetrical figure, right? So this is called a line of, this line is known as what? Where it's got folded, this line is known as what? Beta, line of symmetry. Now, if you want to check that whether this is a line of symmetry or not, so just see, I just folded it like this, right? Just see. But this is not a line of symmetry, right? So here, if you're going to fold over here, this is not exactly overlapping. So it has only one line of symmetry, that is this line of symmetry, right? So every figure, it's not necessary to be asymmetrical about any point. So it has only one line of symmetry, two lines of symmetry. So this is called as what beta, line of symmetry. So let's start with the like the things, and please do it so you'll learn more and you'll enjoy learning things, right? Um, my goodness. Yeah, just see this. Okay, where were we? Right. So you can just do the cutting of the paper, right? Cutting of the design. And this one I have just showed you, right? So let's learn all these things. Now, here, this is an important thing which I want to, that you people should know about it, right? You should know about it. Like, I really want to enlarge this so that you can see very clearly the images and everything. So just over here, just give a close observation over here, that see that the line segment, if you have a line segment has only one line of symmetry, that is known as what beta, the perpendicular bisectors. I'll be just marking out. So this is known as what beta, the perpendicular bisectors of the line. It means what? This is going to be what? This is equal 90 degree and this is equals to this, right? So if you have a line segment of 10 centimeter and you have to just get it like what is a which line is the line of symmetry. So what you have to do, you have to draw that is a perpendicular bisector of it, and that is why the line which is like passing through what beta, the line which is passing through 5 and which is at 90 degree, right? Now, what is the other things which we have? What is an angle? Angle has only one line of symmetry, that is the bisector of the angle. Means what is what divided into what? 2 equals half, right? So you have any angles like this. So this is like 60 degree. So what is the line of symmetry? The line of symmetry will be what? This is the line of symmetry. So this will be 30 degree and this will be what? 30 degree, right? Now, let's talk about the scalene triangle. Scalene triangle has, what do you mean by scalene triangle? Triangles which have all the sides unequal. So scalene triangles have no line of symmetry, right? What is an isosceles triangle? Isosceles triangle means what? The two sides are equal. So an isosceles triangle is like, it has only one line of symmetry, and that is the bisector of the angle included the equal side, right? So let us suppose if you have an isosceles triangle like this, right? So this and this are isosceles. So the line of symmetry cannot be drawn like this. No, it's no. But it has to be what beta? If this and this side is equal, then we say that this is a line of symmetry and this is going to be 90 degrees. So this one is what beta? Line of symmetry, right? Now let's talk about an equilateral triangle. Equilateral triangle has three lines of symmetry. So it's like this, and like this, right? So the line of symmetry, it has the three lines of symmetry and the bisectors of all the angles, right? because equilateral triangle means what, all the angles are what, 90 degree, and all the sides are what, equal, right? Now let's talk about the parallelogram. Parallelogram has no lines of symmetry. What is a parallelogram? Opposite sides are equal and parallel, that's it, but it does not have, right? What is in trapezium? As I have told you, trapezium means that trapezium will have no lines of symmetry. But if I talk about an isosceles trapezium means what, non-parallel sides are what, equal or not? Non-parallel sides are what, equal. So can you just divide from here or not? So it has only one line of symmetry, that is the midpoint of the base of the trapezium, right? So there are the other figures, please, that's why I'm using this, because it's really important for you to know for the small little things, that what are the lines of symmetry, how many lines of symmetry it will have. So let me just enlarge this also. Yeah, yeah, just see. Coming to rectangles, rectangles have only two lines of symmetry, that is the horizontal and one the vertical. This is what, beta, vertical line of symmetry, right? Vertical line of symmetry, right? Line of symmetry, right? And the horizontal line of symmetry. It does not have a diagonal symmetry, right? So this is what, beta, only horizontal. This is what, horizontal line of symmetry, right? Line of symmetry, right? So if you have a rectangle with you, let us suppose I have a rectangle. This is a rectangle. So if I'm going to join this diagonally, it's not going to be what, beta, overlapping to each other, right? I think so. You can see this, right? It's not overlapping, right? It's not overlapping. So no, rectangle have only what, beta, this is one and this is the other, right? And as I've shown you, what is a rhombus? Rhombus also we have studied. Rhombus is a parallelogram in which all sides are equal and parallel. So it have only opposite angles are equal. So it have the diagonals as the diagonals are going to what, beta, divide this into two equal parts. See, so it have two lines of symmetry. Now let's come into the square. Square has what, how many lines of symmetry? See over here, square is going to have four lines of symmetry, right? It will have four lines of symmetry. That is the midpoint. So if you just see this, so this is the one line of symmetry. This is the other line of symmetry. It have what, diagonal symmetry, horizontal symmetry, and it have vertical, horizontal, and diagonal symmetry. So this one is going from the diagonal. So this is having what, beta, diagonal symmetry, right? Diagonal symmetry, right? Yeah, and the rhombus have only diagonal symmetry, does not have horizontal or vertical. So this is known as what, beta, diagonal symmetry, right? Diagonal symmetry, right? Okay, now let's coming to the figure. Now if I say, let's talk about, as you have seen above, right? As you have seen above, mm, there is no pentagon. Okay, just see over here, beta. We have seen that equilateral triangle is what, a regular polygon. Regular polygon, I have told you in the previous classes also, what is a regular polygon? That is a polygon in which all sides and all angles are equal. So for triangle, it is what, beta? For three-sided polygon, it is what, equilateral triangle. For four-sided polygon, it will be what, beta? And a square, because squares of all sides equal and all angles are equal. Now let's talk about a regular pentagon. So regular pentagon, it will have how many lines of symmetry? It will have five lines of symmetry, right? So it will have five lines of symmetry and the perpendicular drawn from the vertices to the opposite side, right? So what do you mean by this? Like from here, you're going to drop a perpendicular. So this is the first, this is line L1, right? You drop the second, yeah. So this is the second, L2. Now let's see this. This one is what, beta? L3, right? This is L3, and this one is what, beta? L4, right or not? This is 95, and this one is what, beta? L5. This is line 5. Now you just see one thing, that is for a regular, specifically for a regular polygon, if it is having three sides, how many lines of symmetry? Three symmetry. If it's a four-sided polygon, it's a regular polygon, then it is having four sides of four. It is having what, beta? Four lines of symmetry. If it is a regular pentagon, that is a pentagon is what, it have five sides, it will have how many lines of symmetry? Five. But if it is an irregular, it's random, so we cannot say. But if it's regular, then it's for sure. Now if you see this clearly, beta, if you see that for a regular hexagon, right? For a regular hexagon, if you see, for a regular hexagon has how many lines of symmetry? Six lines of symmetry, right? And it said the line joining the opposite side and the diagonal through the center, right or not? So this is going to be what, again, one. So this is going to be what, one, right? This is going to be two. So this is what, vertical. This one is what, beta? Diagonal. This one is like again like this. This is L1. This is L2. This is L3. Now just see this. This one is what, beta? L4. This is horizontal. Then this one is like normal, right? right? This is what L5, and this is passing through the diagonals, right? So this is what beta L6, right? So 6 lines of symmetry. So we got one thing from star, that for any regular polygon, lines of symmetry is equals to number of sides, right? So if I ask you the question, that is lines of symmetry of regular octagon. Octagon is how many sides, beta? 8. So it will be having how many, that is lines of symmetry? 8, right? So let's coming to the kite. Kite is a one, like if you see that kite means what? This side is equals to this side, and this side is equals to what, beta? This side, right? So you see that there will be only one line of symmetry which is passing through the diagonal. So it have only what, beta? Diagonal symmetry, right? Shown about the diagonal. Now, what is an arrowhead, right? You have seen, so this is like again like this. So this side is equals to this, and this side is equals to this. So only one line is there. So we say that this is only having only one line of symmetry, right? Which is passing through the diagonal. Now let's coming to the alphabets. Okay, let's coming to the semicircle. Semicircle means what? Half of the circle. So I don't have a circle right now, but I can draw one circle from here with this thing, right? I can just draw one circle like this. It won't be a nice circle, but yeah, I'll try to make something. Yeah. This is a circle, somewhat a circle. It's not like a circle, it's look like a pen. You need a compass to draw this, right? I don't have compass. So yeah, it's look like a circle, right? So if you see this, this is an entire circle. So this is what a semicircle. So semicircle divided into how many parts, beta? Only just one part, right? That's the line. Only one line of symmetry, right? But if you talk about this circle is like as a circle is what, beta? Circle is a polygon. You can say it's not a polygon, it's like a limiting case of a polygon in which of like a number of sides is infinite, right? So a circle have what, beta? Infinite numbers of what, beta? Circle have what, beta? Infinite numbers of the symmetry, that is a perpendicular bisector of the diameter, and the circle have infinite means what? Uncountable numbers. You have like how many diagonals? Like every diameter is what? Line of symmetry, yes or no? So every diameter is a line of symmetry. So how many diameters? It means what? Uncountable, right? Uncountable, right? Okay, now let's coming to the letters, right? So let's see these letters. So you have all the letters, not all the letters, some of the letters, because every letters in the English alphabets do not have like F do not have any lines of symmetry. So here there is a discussion of the letters which have lines of symmetry, right? So we have like 15 letters out of 26 which have the lines of symmetry, and the others do not have, right? So just keep it in the mind, that is the O, right? This O have only 2 lines of symmetry. It does not have infinite lines of symmetry, because we write O as like this. We don't write O. This O is kind of oval. We don't write O as a circle, right? O is not a circle. So it's like it does not have infinite. It have just 2 lines of symmetry, right? So these are the letters like A, B, C, D, E, H, I, M, O, T, U, V, W, X, Y. Z does not have, right? N does not have, R does not have, S does not have, right? So if you say that, ma'am, S does not have lines of symmetry, if you're going to fold it, it will not going to overlap each other row. So no, S does not have, right? So here are the some examples which you will be seeing over here. Okay, so if you see that, okay, okay. Now just see this example. For the given figure, which one is the mirror line, L1 and L2? So obviously beta L2, L1 is not, right? So L1, 2 is the mirror line. Now check whether the given figures, now let's do the example number 2. Let's talk about the example number 2. Okay, so it says that over here, check the whether the given figures and the pictures are symmetrical or not. In case a figure is symmetrical, then draw the lines of symmetry and count their numbers, right? So first one is, yes, you can draw a figure like this. So you have one, right? This figure also, yes. So you have 1. This figure, no, nothing. We can draw this from here. Yeah. This one is from here. Is this a square or this is one is a rectangle? This looks like a square, right? Square, let's just see the answers, okay? Let me just see because yeah, it's a square only. It's a square. Okay, it's look like for me sometime on the board it's very difficult to understand. So yes, it's a square. So it will be 1, 2, 3, 4, and this is a square. So this is a what? A regular polygon, so it will have 4. Now let's see for this how many it will have, like 1, right? Obviously 1, and this is going to be what, beta 2. What else you can see that you can draw the diagonal one, the x? Yes, you can have this also. Yeah, if you're going to draw from here, so it's going to what, beta overlap, right? And if you're going to draw this from here, so it will have again what, 4, right? They have drawn just one. Why? Because you can just draw. Okay, they have drawn this. Okay, they have drawn this. So this will have what, like this. Okay. Now, coming to this one. So this is having only just one, like this one. And this is from the middle point of it, right? So this is one. Yeah. So if I draw from here, if I draw from the middle from here, so yes, this can be, yes. And if I draw, this is L1, this is L2, this is L3. Now can I draw it from here? Yes, and this one is what, L4. So 4 lines of symmetry, right? So diagonal, horizontal, and vertical. Now let's coming to this one. Let me change the color. So this one, this is a star, right? So what do you see over here? You just see that this is an hexagon and which in which the star has been made, right? So this is equals to how much? If you see, if you're going to draw this one, right? This is L1 and this one is what, beta L2, right? And this one is like you go with the vertex L3, right? Hmm. Wait a minute, let me just see the figure. Wait a minute, it's like really very much impossible for me, the visibility. Wait a minute. It's really, really difficult. Okay, this was L3, right? Okay, just for you, you just see. This is one. Mm. Oh, over here, if you just see this also, just see this once again. But let me just do this question again, okay? Because I feel like I did some, I really need to make this a little bit large. Wait a minute. Because it's very difficult for me to like see now. I think so it's okay for me. Now, let's draw this, okay? Now, this will be how much bigger? Like this one. And this is for 2 for sure, right? L1 and L2. Now, if I draw this line from here, right? Now, this is going to fold on this, but this side is not going to fold on this. So it will have only 2 lines of symmetry. Yes, that is not having 3. Okay, now let's come into this. It says that from here to here, that's 1. This is L1. Okay, now and you can draw from here also, right? So this upon this and this will overlap to this. And this will overlap because all sides are equal, right? So this is what beta L2. right? Coming to this part, this is L3, right? Coming to this part, like this is an hexagon also, so this is what beta L4, right? Now coming to this side, right? This is what L5, right? Now coming to this side, this is what L6. We got this all L1, L2, L3, L4, L5, L6. There will be six, right? Now coming to swastik. Swastik will have nothing, right? It has like nothing, so not symmetric, no. So we drew here. I drew once, right? One. This is no. I don't know where it went. I think so. I rubbed all. So this is one, two, right? So two, and this one is what three, and this one is what bit of four, right? Now let's see this. This is like one, and then we drew two, and then we drew three, and then we drew four. So yes, four lines of symmetry. What about this one? So this is going to have only just one lines of symmetry, right? This and this, only one, right? Can we draw this also? Yes. This will block will come over here, right? So this is 2, right? This will having a 2, right? That's correct. So let's just match our answer. Okay. Okay, this is down, this is down. Okay, so yeah, yes, it's matching. Okay, now let's see where we are going. Like this is the last page. Let's do the question on this also. Okay, copy the figure. It says that copy the figure. Let me just wait a minute. Let me just enlarge it. What I'll do, let me just enlarge it a bit more because I need to solve. Let me just bring this down, more paper down, and enlarge it to a little bit like this. Yeah. Okay, just see over here. What the question says that copy the figure on the square papers and draw the lines of symmetry, if any. Then count the numbers. So this one is symmetric about anyone. So you just see this is what in scalene triangle, right? Looks like a scalene triangle, like 1, 2, 3, 4, 1, 2, 3, 4. No, this one is a scalene triangle. Yeah, this is like if you're going to draw this, it's not going to overlap. If you're going to draw this also from here, right? You're going to draw from here. 1, 2, this, and this is like 1, 2, 3. So it is having none. Just see over here. Just see over here. So this is going to be, you're going to draw from here, right? From somewhere here. So it's not going to overlap exactly on this. So it is having none, right? This one is very clear. So this is only having only one line of symmetry, right? Yeah, this is only one. Now let's just see this. This is for one, this is for sure. And this is the second, right? And this one is again like 4 because this is in square. Let's just check this is a square or not. Like 1, 2, 3, 4, 5, 6, 7, 8, 8, and 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So 8 and 8. So this is what a square. So it will have a 4 lines of symmetry, right? From here to here, right? Now let's coming to 4 lines of symmetry. Now let's coming to this one. If you draw this, this is for sure, and you draw this. This is like clearly visible too. Now just see this. This one is like 1 for sure, and that's only 1, right? Right? Coming to this, it will be having this much, just 1. This is 2. If you're going to draw this, the diagonal, because this is going to overlap on this and this is going to overlap on this. So this is L1, L2, L3 and L4. So it is having 4 lines of symmetry, right? Coming to the sixth part, beta. Can you draw a triangle which has one line of symmetry? So one line of symmetry is by basically only having by isosceles triangle, right? Isosceles triangle, right? So this is how you're going to draw this. right? This and this will be the lines of symmetry, right? Yeah. Now coming to the second, see exactly two lines of symmetry. No triangles have any lines of symmetry. So no triangle have exactly two lines of symmetry, right? Right. Now coming to the third part, it says that exactly three lines of symmetry. So we know that exactly three lines of symmetry will be having by what bit? An equilateral triangle, right? So this is why by equilateral triangle all sides are like this. So this and this, right? It will this. Yeah. So this is will be what beta equilateral triangle, right? Coming to the fourth part, it says that no lines of symmetry. So it will be what beta scalene triangle, definitely scalene triangle, right? So this, like this, and this is what in scalene triangle. Sketch a rough figure in each of the cases and name the triangle. So we have done with all of the part. So I think so you have understood this part. In the next class, we'll be doing the questions like we'll be doing the what is the reflection. So next class we'll be doing the reflection, and that will be the end of the chapter. So thank you, class. And if you have any doubt, please ask it on the PDF. That is a batch discussion forum, or you can just ask with your respective teacher in the class. And I hopefully you have understood the symmetry chapter very well. And thank you so much, class.